Okay, now we're looking at the 30, 60, 90 triangles. The 30, 60, 90 special triangle is special because it is actually half of an equilateral triangle. If you have an equilateral triangle, for example, like so, if you recall, an equilateral triangle has angle measures that are each equal to 60 degrees. And that makes sense because 60 degrees plus 60 degrees plus 60 degrees is equal to 180. So every single equilateral triangle has angle measures equal to 60 degrees. If you split the equilateral in half, you will have split this angle. If you split this one, what will be the length of this part of the angle? Of course, we can see it is 30 degrees. So we have created another triangle out of the original equilateral with angle measures of 60, 90, and 30. And this makes sense because if you add it, you get 180. Notice here when we drew the line down to the base, we created a 90-degree angle. This new triangle has a hypotenuse, which is opposite the right angle symbol, a shorter leg. The shorter leg is always adjacent to the 60-degree angle, and a longer leg. The longer leg is always adjacent to the 30-degree angle. This is a 30, 60, 90 triangle. The relationship between the three sides of a 30, 60, 90 triangle can be found using the Pythagorean theorem. If we look again at the original equilateral triangle, we see that it has an altitude of h, a right angle, 60 degree, and obviously this one up here has to be 30. If we plug in the height and the base into the Pythagorean theorem, we get s squared plus h squared equals, why did we use 2s? Because this is an equilateral triangle. That means that this part is also s. So the whole side length is 2s. Since it's equilateral, the other sides are also equal to 2s. Not 25, it's 2s. So we plug 2s into the Pythagorean theorem and we get s squared plus h squared equals 4s squared. So we squared the 2 and the s. If we bring the s squared to the other side, we get h squared equals 3s squared. So we brought this to the other side. Subtracted s squared from both sides. We square root that and we get h equals the square root of 3s squared. Well, s squared comes out of the radical as s. 3 stays inside the radical, so our height is s radical 3. So the length of this side is s radical 3, which also happens to be the longer leg in the 30, 60, 90 triangle. So the general pattern in the 30, 60, 90 triangle is that the hypotenuse is twice as long as the shorter leg. So the shorter leg is always x. The hypotenuse is 2x, or twice as long as the shorter side. And the longer leg is radical 3 times as long as the shorter leg, or x radical 3. This is what you need to memorize, that the 30, 60, 90 triangles have this pattern. It's x, x radical 3, and 2x. Okay, so let's find side lengths in this 30, 60, 90 triangle. If the shorter leg is 6, which also happens to be x, what would be the height? That's right. If we look back at the previous slide, we can see that the longer leg is the same as the shorter leg times radical 3. So if this is 6, what would h be? That's right, 6 radical 3. We multiply the shorter side times radical 3 to get the longer side. And then the hypotenuse is always twice as big as the shorter side. So if the shorter side is 6, the hypotenuse is 12. So b is 2x, 6 equals, x equals, 6. So b equals 2x, and at h equals x radical, x radical 3. Here we have another example. We have the hypotenuse, but we don't have the legs. Well, let's follow the pattern. The shorter leg is always equal to x. The longer leg is always equal to x radical 3. And the hypotenuse is always equal to 2x. Therefore, if the hypotenuse is equal to 2x, that means 8 equals 2x. So what is the length of x? We divide both sides by 2, and we get x equal to 4. So the length of that shorter leg is 4. The length of a longer leg is 4, because x radical 3 is the longer leg. X equals 4, so we just write radical 3 right next to it. So the length of that longer leg is 4 radical 3. Here we have to find the side lengths in a 30, 60 degree, 30, 60, 90 degree triangle. This is the most difficult example, when you're given the longer leg and you have to find the other two legs. The longer leg is always equal to radical 3 times the shorter leg. Well, in this case, the longer leg measures 5. So we're going to write 5 equals radical 3 times s. That's what we're given. The shorter leg's length is s. So we have to solve for s. We divide both sides by radical 3, and we get s is equal to 5 divided by radical 3. But as you remember, you cannot leave a radical in the denominator, so we must rationalize this. So we're going to do 5 radical 3 times radical 3 over radical 3, and we get 5 radical 3 over 3. And that is the length of the shorter leg. Now, how would we get t? Remember, t is the hypotenuse, and the hypotenuse is always twice the length of the shorter leg. So we do 2 times 5 radical 3 over 3. And we get 10 radical 3 over 3. That's the length of the hypotenuse t.